Hi everyone, this is the video lesson for 4.4, Concavity and Points of Inflection, Part 2. Now if you haven't watched Part 1 yet, make sure you go back and watch it first before continuing with this Part 2 video. Now in the first part we ended with example number 2, and I kind of mentioned at the end that the only inflection points are 1, 1/4, and -1, 1/4. Now I'm going to give you a little bit more. With practice, you can always double check your work by drawing a diagram either with Desmos or in this case, I'm going to draw one with you manually. So notice the scale. I'm going to go up and down, left and right by 1. If you look at the points of inflection, they are at 1 and 1/4, -1 and 1/4, and of course, if you go back a little bit and do a bit of mental math, you can find the Y-intercept. To find the Y-intercept, you have to set x to be 0, and in this case, 1 divided by 0 squared plus 3 is going to be 1/3. So the Y-intercept is going to be located at 0, 1/3. And I just want to illustrate this without doing all the steps yet, that when you graph this, it's going to be concave down when it's between -1 and 1, then it continues to be concave up everywhere else. And there'll be a horizontal asymptote that looks something like that, and that is the function. So again, at any given time, if you want to double check your work, you can draw a graph, either manually, maybe use Desmos, and that's the best way to maximize your mark. Now, here we go. We're going to continue with example number 3. Determine the interval of concavity for the function f of x equal to x cubed plus 8 divided by x. So again, to find the points of inflection or to find the intervals of concavity, first you must find the second derivative. So I'm going to copy down the function x cubed plus 8 divided by x. Now you know there are two ways of doing this. For some students, they're going to look at this and say, let's break it apart as x squared plus 8 over x. But I know for most of you, because you see a fraction, you're going to jump straight to the quotient rule. So again, I'm not saying this is the fastest method, but I think this is the most common method, and I'm going to go through it from your perspective. Again, when you find a derivative, there's 6 steps. Using the quotient rule, step 1, square the bottom. Step 2, you're going to copy the bottom to the top. Step 3, you multiply by the derivative of the top, minus. You copy the top. And the final step, you multiply by the derivative of the bottom. Now, if you clean this up a little bit, y prime equals to 3x cubed minus x cubed minus 8 all over x squared, which means y prime equals to 2x cubed minus 8 divided by x squared. Now, I'm going to continue. In the next column, I'm applying the quotient rule again. I'm going to find the second derivative. So, again, step 1, I square the bottom. That's going to be x to the 4. Step 2, I copy the bottom to the top. Step 3, I multiply by the derivative of the top minus. I copy the top, which is 2x cubed minus 8. And the final step, I multiply by the derivative of the bottom. Now, before we keep going, notice how there's a common factor of x from the top and the bottom. So you can cross that out. And now you can set this to 0. That's exactly how you find inflection points. And if you look at the top and you clean this up, that's going to be 6x cubed minus 4x cubed plus 16 all over x to the power of 3. Now again, notice I'm not going to focus on the denominator. If I take a step back, by inspection, you can tell that there's a vertical asymptote located at x equal to 0. So even though You do want to find out when f double prime will be undefined, or for some people, they look at it, it does not exist, it's really undefined. That becomes the vertical asymptote. We're still going to use this in the divider when we go through intervals. However, that's not really an inflection point. So you only focus on the numerator. So 0 is going to be 2x cubed plus 16. And in this case, when you solve for x, first of all, again, you can factor a common 2 from both sides. You can bring it over. X cubed equals to negative 8. The opposite of cubing something is to find the cube root. There's only one case that you're focusing on. There are only two cases when you're taking the square root or even root. So x equals to negative 2. Again, from that habit, always find the location, not just the x component. If you plug negative 2 back in, again, I'll do this with you mentally. You can use the calculator if you like, that's fine. When you plug in negative 2, that's going to be negative 2 cubed, which is negative 8, plus 8, that's going to be 0, divided by a non-zero, so it's going to be 0. So the inflection point is located at negative 2 and 0. Now, you're going to draw this number line. And this we did even with the other lessons from before. Here's the mistake. If all you do is you write down negative 2 like that, this is not how you do it. You have to remember, even though the only inflection point is x equal to negative 2, the dividers must include any vertical asymptotes. So the fact that we knew there was a vertical asymptote at x equal to 0, you have to go back and include that. So if you make this mistake, that's okay. Mistakes are our friends. Our friends are not, you know. Now, if you plug it back in, it's going to be negative 2 and 0. So again, negative 2 is the inflection point, and 0 is the vertical asymptote. So when you look at this, you can plug in different numbers. So for example, you can focus on what happens when x is less than negative 2, what happens when x is in between negative 2 and 0, and what happens when x is greater than 0. And it goes to plug it back into f double prime. So again, I'm just going to write f double prime at the top. And if you clean this up a little bit, the bottom is still going to be x to the power 3. If you look at the top, this becomes 2x cubed plus 16. So you can take the calculator, you can do mental math, it's up to you. But let's say you pick a number less than negative 2. Let's say you pick negative 3. When you plug it back in now, this is 2 times negative 3 cubed plus 16. That's a negative number. Divided by negative 27, that's a negative number. So negative divided by negative, that's going to be positive. Likewise, you can pick a number between negative 2 and 0. Let's say you pick negative 1. If you plug it back in, that's negative 2 plus 16, that's positive, divided by negative 1, which is negative. And again, positive divided by negative is negative. Last but not least, if you pick a positive number, let's say 1, it's going to be positive over positive. So, in terms of the answer to this question, the final statement is going to be, therefore, the function is going to be concave up for x less than negative 2, or when it's greater than 0, and the function is going to be concave down for x in between negative 2 and 0. Now, the only thing I want to add, of course, is the fact that the vertical asymptote exists at 0. You can draw a circle there just to kind of block that out. And technically, that's the inflection point, so that's also not part of your consideration. Okay. Example number 4. This is question number 9 on page 206. So, let's take a look. Sketch the graph of a function with the following properties. F prime is positive when x is less than 2 and when x is in between 2 and 5. F prime is less than 0 when x is greater than 5. f prime is 2, or f prime of 2 equals to 0, and f prime of 5 equals to 0. F double prime is negative when x is less than 2, and when x is in between 4 and 7. F double prime is greater than 0 when x is in between 2 and 4, when x is greater than 7, and f of 0 equals to negative 4. So at this point, try it, and when you're ready, you can press play, or maybe I'll stop the video here and you can watch part 3 for the answers. I hope this makes sense.